Hello and welcome to Startup Hack. Today we are going to discuss about why immutability is important in .NET C#. This is one of the most interesting topics to me to the extent that once I start talking about it, you might need to fight me to stop. I believe that many of the issues and problems that developers come across could be solved if they apply immutability as it should. So let's get started. So today's agenda is number 1, what is immutability? Number 2, common mistakes violating immutability, in which we will see private setter, internal manipulative code, read or write collections, read-only collections of mutable objects, mutable member object. Number 3, how to not violate, and number 4, advantages. So let's dig in. Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started. So what is immutability? In the software world, immutability means that you define your classes and struct in a way that the object could not be manipulated or updated once it's created. For example, let's say you have this class. Now creating an instance of the employee class could be as easy as this. However, you can still update the first name of the object, John, by doing this. In this case, the employee class is not following the definition of immutability. If we want to fix the employee class to really follow the definition of immutability, we need to update the class like this. As you can notice, we removed the set from the first name property so that the only way to set its value is through the constructor. This means that the object could not be modified after being created. Now you might think, is that all? It's too easy. However, there are some mistakes some developers might do. They might think that they did what is needed to make their classes and structs immutable when they actually didn't. Alright, let's move towards the second topic, common mistake violating immutability. There are some of the mistakes that developers might do violating the immutability rules. So number 1 will be private setter. Let's say we have this code. As you can notice here, we don't have a public setter on the first name property. However, we still have a private setter which opens the door to internal manipulations. This means that any piece of code inside the employee class can still update the value of the first name property, which leaves the object mutated. Okay, now internal manipulative code. Let's say we have this code. As you can notice here, employee class exposes a rename method that would update the value of first name property. This for sure leaves the object mutated. The third mistake is read or write collections. Let's say we have this code. As you can notice here, the managed property is not exposing a public setter or even a private one. However, the type of the property itself is a list which is open for write. This means that we can do the following. See here, we can add a new employee instance inside the managed list. This for sure leaves the object mutated. The fourth mistake is read-only collections of mutable object. Let's say we have this code. As you can notice here, the telephone numbers property doesn't expose any public or private setters, and its type is read-only collection, which doesn't allow for adding or removing items from inside. Now, you might think that your object is safe and no one can mutate it, right? Let me show you something. Let's say that we have this code. See, we can still manipulate the object because the underlying object inside the read-only collection is mutable. Now, the last common mistake is mutable member object. Let's say we have this code. As you can notice here, although the telephone number property is not exposing any public or private setter, still the type of property is telephone number, which is mutable. This means that we can write some code like this. This for sure leaves the object mutated. Now I can hear you're saying, what is this? I now think it is impossible to achieve immutability. How can we write code which doesn't violate any of these rules? Take it easy, you might think so, but actually it is not possible. Okay, now the next topic is how to not violate. There are some golden rules to follow to achieve immutability. All fields should be read-only. All properties should be provide getters only. All members should be of immutable types. All collections should be immutable. In case a method needs to update the internal state, it should keep the internal state untouched and return a whole new object with the new state. If you follow these rules, you would end up with the fully immutable object. Okay, now I can hear you asking, does it really worth the hassle? Would I gain anything from doing all of this? Absolutely. Although it seems too much to follow these rules, believe me, you would get many benefits in return. So now, what are the benefits? Based on the fact that the object could not be mutated after being created, there are a lot of advantages we can get. Thread safety. Since the object is guaranteed to be immune against any manipulation, we don't care if the object would be accessed by one thread or more. At the end of all these threads would not be able to update the object, so why not to be accessed by more than one thread? Singleton. Since the object would always hold one and only one state at a time, then we can use this object as a singleton. It is like integers. If I tell you that you have an integer with the value 3, would you ask me which instance? I think no, as it doesn't matter. If it is 3, then it will be always 3. Less memory allocations. This is because you can define the object one time and use it many times. You can also define the as a singleton. You can also cache it somewhere. Additionally, you can avoid automatic copying by passing the object by reference or using int parameters. All of this would save money, memory allocations. Compiler optimizations. Defining a struct as immutable would make it so easy for you to also define it as read-only using the read-only keyword. This would also help the compiler avoid defensive copy mechanism, which would eventually save processing and memory, leading to a performance boost. The last advantage is caching. Since the object would not be manipulated after being created, the object could be used as a key in a dictionary or safely cached in a cache collection. Additionally, it would be easy to avoid duplication, which would save memory. So that's it. I hope you starting from this moment you will appreciate immutability and try to apply it as far as you can. So don't forget to subscribe our channel and hit the bell icon for latest update. To joining our course, you can simply go to our website called startuphack.com/start-now. Thank you.